Solving logarithmic equations then, based on all the stuff that you've known so far, has two possible scenarios. Scenario one, make them both logs with the same base. Because if you can cancel out the logs just like we do exponents, and then you find out that p equals to q. The second way of doing this is, of course, if you have something like this, you turn around and you say, okay, I'm going to take the log of both sides and I'm going to go, and then I'm going to remember the log can actually just be exponential form. Take the a to the power of q, that equals to p. See, a to the power of q equals to p. But here's one of the most important things that happens. You got to verify. The reason why you have to verify is because, remember, the argument of the logarithm is not allowed to be 0 and it's not allowed to be negative. That's just because of the way the graph looks. Remember, the graph looks like it hugs this, comes this way, so can't be 0, and there's nothing over on this side, so can never be negative. Oh boy, oh boy, oh boy, we just opened up a big can of worms, didn't we? Well, actually, yes, we did. So let's go. Okay, we're going to go question by question here, and we're going to just do a whole bunch of podcasts to make you all happy. Okay, here we go. Let's do it. First things first, let's look at A, and we'll do A and B, and then C and D in another podcast. All right. Okay, how do we go about doing this one? Well, I think the clue here is simply the fact that these are all base 2s. You see how they're all base 2s? That means you're going to probably put them together. All right, so watch what I'm going to do. Real simple. And every time I've done this question, I've done it differently. So you can actually do all kinds of neat things here. Okay, enough talk. Let's rock. All right, so I want that number in terms of a log 2, right? So let's think about it. I want the number in a base of log 2 to equal to 5. 2 to the power of 5. Oh, look at that. 2 to the power of 5, if I'm not mistaken, is 32. So I can put 32 in right there. So I'm going to replace this number 5 with log base 2 of 32 because it works out to be exactly the same number. This equals to, look at this. Because they're common bases, look what I can do with this. I can multiply them. Fantabulous. Look at this. This is going to be log base 2 now of x times 2x, which is 2x squared. And like I said before now, guess what? You can cancel out the common log to give you 32 equals to 2x squared. Divide by 2, you got 16 equals to x squared, square root, x equals to plus or minus 4, right? Wrong. You got to make sure that it satisfies the rules of logarithms, right? So go out and just start by putting it into the simplest log. Try it. Yes, you can find the log of positive 4, but look what happens when you try to do the log to base negative 4. Look at that. You can't. You're not allowed to do those. So guess what? Your only answer is x equals to plus 4. That's it. There is no negative on this one. Got it? Okay. So let's do question B now, and I'm going to show you how to do that one. Hold on. Let me clean this up. Watch how to do this one. This one's really nice. Everything looks like a common logarithm, doesn't it? The only thing that you worry about is you got a crazy 2 up front here, right? So what? It's a power. Bring it back in. Look, you got log x to the power 2 now minus log of x plus 2 equaling to log of 2x minus 3. And the beauty of all of this is they're all the same basis. So now just apply the log laws. This means subtract. So guess what? This is going to be the log of x squared over x plus 2 equals to, look at this, the log of 2x minus 3. And look, lo and behold, they're nice logs on each side. Now that they're all together, you can cancel them. And what you end up getting is you end up getting x squared over x plus 2 equals to 2x minus 3. Look at that. All you have to do now is cross multiply. Yes, this is going to give us x squared equals to x plus 2 times 2x minus 3. Right? Doing a little bit of FOIL magic here, you're going to have x squared equals to 2x squared. Ba-da-ba. Right? Minus 3x plus 4x gives you plus x. And then, of course, 2 times minus 3 is minus 6. Bring that x squared over. You're going to end up with x squared plus x minus 6. And you know the factors work out to be x. Oh, what would that be? X plus 3, x minus 2, and your values are x equals to minus 3 and x equals to positive 2, right? Wrong. Don't forget, you still have to check to make sure that those values work. So go back into here. If you put a minus 3 into there, you're trying to take a log of a minus. You know and I know that doesn't work. So your only answer is 2, right? And that works out just spectacularly well. Next podcast, we're going to look at a few more. Hang tough.